Hello, my friends, and welcome to another lesson about the work of air. We've been talking a lot about the air and about the wind and about how the air moves across the land. It's constantly moving and constantly blowing. And it's not just blowing across the land, but it's blowing across the water too. And I want to show you something cool. But before I show you that, I'm going to show you how to set up what I'm going to do so you can do it yourself. There's a couple things you're going to need. You need some kind of a basin or dish. This is a casserole dish, a glass casserole dish. And so it's pretty big, but it should work very well for our experiment. The other thing you're going to need is some rocks, or a piece of a brick or a rock, and be careful with that too. But we're going to use that a little bit later in this activity. The other thing you're going to want is a straw or something that will help direct the flow of air from your mouth into a very specific direction. Something sort of light and floaty. In the classroom, we like to use sawdust or like really, really teeny tiny wood chips. So sort of like a hamster or rabbit bedding. So if you have one of those living with you, you could borrow some from that little friend of yours. But in here, I've just got holes from a paper punch. I just emptied it out, and I think I've got enough to make this look pretty good. The last thing you're going to need is water, and that's going to go right in here. So why don't we pour that in? And we are ready to blow. I would have said go, but this is a wind lesson. So watch what happens. I'm going to sprinkle these into the water. Oop, that one doesn't match. Okay. So check them out, floating around. Now we can sort of see the water and how it's going to move. I'm going to take my straw and show you something really cool. Ready? What do you see happening? Can you see the air moving? No, of course not. It's very, very, very expansive and hard to see. But what do you see moving? You see the water. And it's sort of hard to see too. If there wasn't anything floating in it, it would be much harder to see. But you can see that the air has moved the surface of the water, and that's causing those particles to move around. Now, I'll try it again, and let's do it at a different angle this time. And so you can see that movement, that current starting to develop. Look at that. Maybe it'll be a hurricane. Well, hopefully not. But the thing is, our ocean does this too. The air moves across the surface of the water and moves it around. But our ocean isn't one big dish of water with nothing in it. There's things like this in it. Continents, right? So why don't we put this obstacle in here and let's see what happens. Let me move that just a little bit so you can see what's about to happen. I'm going to grab my straw again and I'm going to point it right at that continent. Watch what happens. Now, think about this in a larger scale. There's a big continent, here comes the air, and what happened? It sort of diverted, right? Or we say it deviated. It found its way around, but maybe some had to go up and around in here, and there's a little cave there. But generally, the water is moving around, and right now you can still sort of see that current. There's this current swirling here. Some of it's leaving and going around, and actually coming almost all the way back to where it started. So we get currents that deviate as well. Could be pretty cool. And you could try putting multiple continents in your experiment and seeing how that affects things. But we can give names to these currents too. We can call them warm currents when they come from somewhere warm. We can call them cold currents when they come from somewhere cold. And then when they meet, they might even sort of mix like this or like that, and we'll get, surface currents and deep sea currents. And, there's names for all sorts of different currents depending on where they are. In fact, I got something really cool to show you. If you have a globe or an atlas, check it out. There might even be some of those currents on there. And on this globe, there actually are currents. It not only shows you the currents and as in the direction that they go, but it also names them too. Here's the South Equatorial Current. I bet you know where that comes from. And do you think that would be a warm or cold current? Oh, we'll get into that on another day because we will talk about warm and cold currents. And I have a fantastic experiment for you to do related to that. But for now, give this one a try. And what I'd say is when you're done with it, draw some pictures. Draw out those dishes, draw several of them, show those different placements of continents, and draw the direction of those currents. I have put an example on the drive for you to check out to get you started on that kind of work. But you may also grab a blank map from the drive and you can draw the currents that you can find on your globe or in your atlas. And we'll talk more and more about these. But before you get blown away, go ahead and deal with those two types of currents, those nice currents and those more deviated currents. Have fun, friends.